Hello guys, today we are going to look this problem. This problem is contain one large sphere having radius r. A is the center point. Okay. Now one sphere having the radius r by 2 is removed from this sphere. Okay. This sphere have a uniform charge density. So we have to find out the ratio of electrical field intensity at point A upon electrical field intensity at point B. Okay, what else they have given? Okay, the radius of this small sphere is r by 2 and the radius of the bigger sphere is the r. Okay, now how to solve such kind of problems? That means a sphere having a radius r by 2, this portion is removed from this large sphere. So point A is the point which is on the surface of the sphere having radius r by 2, and for bigger sphere the A is the center point. Okay, so for bigger sphere point B is on its surface, while for this small sphere the point B is at a distance 3r by 2. You can say this is r and this is r by 2. 3r by 2 is the distance. So this is the external point for the small sphere. Okay, so we have to first calculate the electrical field intensity at point A, then electrical field intensity at point B. Okay, let's consider first the electrical field intensity at point A. It is a net effect of electrical intensity because of the complete sphere minus the electrical field intensity because of the cavity. Okay, so A point is the center point for the bigger sphere. So at the center point electrical field intensity is 0. Now for the cavity A is the surface point, and what is the formula? Rho r upon 3 epsilon. So r value is, that means the radius value is r by 2. So what we are getting here, rho r divided by 6 epsilon naught. Now for point B, again we have to calculate. So for point B is, it is a point on surface for the bigger sphere. We can use formula rho into r upon 3 epsilon naught. Here the radius is the capital R. Now point B is the external point for the small sphere. We have to use formula rho r cube upon 3 epsilon r square, where here the r is the radius of the small sphere and the denominator r square is the distance of the point B from the center point of the cavity. Okay, so radius of the cavity is r by 2 and the distance of the external point B from the center of the cavity is the 3r by 2, as we have discussed. After solving this, we will get net intensity at point B is rho r upon 3 epsilon naught 1 minus 1 upon 18. Okay, you have to just solve this. Here rho r 3 epsilon naught, here you are getting this r cube and r square will get cancelled. Similarly this 3, this 2 cube is 8 into 3 24, 3 square is 9, 2 square is 4, 4 6 24, 6 will remain here. Okay, so again rho r upon 3 epsilon naught, rho r upon 54 epsilon naught, you can take common rho r upon 3 epsilon naught. Here bracket we will find 1 minus 1 upon 18, which will yield rho r 3 epsilon naught 17 by 18. Okay, now you have to take just ratio rho a upon, sorry, E at point A upon E at point B. You will get answer is the 18 upon 54, sorry, 18 upon 34. So option D is the correct answer, 18 upon 34. Okay, thank you.